Good morning. We are Aranda Azuara Bautista de los Santos and Sanchez Arevalo, and we are going to present what is Pareto analysis and how can we develop this diagram.
Okay, first of all, what is it? A Pareto diagram is a simple chart that measures the order of occurrence. It was created by Vilfredo Pareto. He was an Italian that studied economist and sociologist. And well, the principal rule is based on the unequal distribution of the things that you want to order in the chart. Next.
Okay. The uses of a Pareto diagram are to identify the causes of the problems and according the level of the importance of the problem. Also, the Pareto diagram is used to visualize the most common aspect to improve in a business, in a process, and also the performance of the machine. And that Pareto diagram, it can also be applied to different aspects, such as positive and a negative. It's easier to identify the best results and avoid the less important aspects that will not help you and achieve the goals. And it's all. Next.
So there are 7 steps to do a Pareto diagram. The first is to identify the problem that you want to analyze, and it's important that you are in constant communication with the collaborator of all the areas or in the department of the problem that you are analyzed, and having a direct communication, it will help you to easier to know the point, to point out exactly the problem or what is not working as it should be. And the second point is to gather the data that will help you assess the problem. In this step, you can make some questions, but the questions depends in what is the problem that you want to solve. But some examples are, for example, are the complaints about the quality of the product, or is about the time of delivery, or about the sales of the product. And it's important to pay attention in everything that is happening around you, around the problem, the area. And also you have to specify a period of time, and it have to be a significant period of time, because if you have a too short period, it will don't it's not that comfortable, because it's a very short time that of data that you can gather. And also it have to be like a real problem, because it can change in the time of in the pass of the time. So it had to be like a common problem. The third point is empty the data into a table. With that table, you can organize the data collected, and this is to contribute to solve the problem. And in this table, you have to put the complaints of your client, if it's the case, or I don't know, the reasons why your sales it's low or or things like that. And also you have to count the frequency and that's it. And the point number 4 is order the data from highest to lowest and calculate their percentages and accumulative percentages. This have the intention, the Pareto diagram have the intention to represent the most frequent problem in order to solve it first. So order the data from highest to lowest will show you the most frequent problem. So you have to solve this problem first. Then you have the point number 5, and you have to do a make a bar graph with this data. And in the vertical axis of the left side, you have to put the factor, the magnitude of each factor, and in the vertical axis of the right, you have to put the accumulated percentage, and in the horizontal axis, you have to put the factors starting with the most important. And then the sixth point, you have to analyze which are the causes or situations that appear at the beginning of the graph. It's important that you analyze very precisely the causes of the problem. So you have to pay attention in what to modify, or maybe you have to add something or change the way that something is made. You have to put attention in what could be um, a solution for that problem. And the last step is to monitor the progress of your proposed solution. So obviously you have to have to monitor the progress of the solution, because you can see if you solve the problem of the problem is appear less. For example, if the problem is low sales, and you propose some solution, you have to monitor that the sales are increasing. So that is a signal that the problem is being solved. Next.
Well, let's start with the first example. So in this case, the first example is that in a textile company, we want to analyze the number of defects in the fabrics that it manufactures. So the following table shows the factors that have been identified as the causes of the problem, as well as the number of defects associated with them. Well, we have the silk, the cotton, the tulle, the taffeta, the the satin, um, the lace, the the wool, and the viscose. So we have here the number of defects. And then next, please. Well, first we have to order the factors from the highest to the lowest based on the magnitude of each one of them. That the magnitude is referred to the number of defects. And then the second step is calculate the total magnitude of the set of factors. Then we have to calculate the total percentage represented by each factor, as well as the accumulated percentage. Next, please. Well, we have to, with the past table, we have to, in order to have to calculate that, we have to use or we have to draw two vertical axes and one horizontal axis in order to draw our graphic. And it's simple to do it, and it's simple to calculate it. So could you go back, please? Well, in the first vertical axis, we have like the percentage of the accumulated, and then we have to give me a minute. Mm, just a minute. Well, in order to calculate it, we have to the percentage is equal to the magnitude of the factor over the total magnitude of the factors, and all of this is per 100. And then the accumulated percentage for each of the factors is obtained by adding the percentage of the previous factors in the list and plus the percentage of the factor itself in question. So please go to the next. Well, we have to draw two vertical axes and one horizontal axis and place the magnitude of each factor on the left vertical. The scale of the axis is between 0 and the full magnitude of the factors, and the cumulative percentage of the factors is represented on the right. Therefore, the scale is from 0 to 100. The point that represents 100 on the right axis is aligned with the one that shows the total magnitude of the factors detected on the left axis. Finally, the horizontal axis shows the factors starting with the most important. We can see as the cotton, the tulle, the silk, the satin, linen, viscose, sail, and all, etc. Will you go to the next one, please? So the linear graph that represents the accumulated percentage calculated previously is represented. This graph is governed by the right vertical axis. Next, we have to write the diagram, any necessary information either about the diagram or idea. The bars corresponding to each factor are plotted. The height of each bar represents its magnitude through the left vertical axis. Next. Well, example conclusion. According to the Pareto analysis, the graph obtained shows that 20% of the fabrics, cotton and tulle, represent approximately 80% of the defects. Therefore, focusing on the company only on these two products will reduce the number of defects by 80%. So we can realize that this with this analysis we can know what is the percentage of the defects and what are the specifically things that give us those problems and those kind of defects, and we can get them out of there, and we can go further, and we can obtain a better process or a better thing that you have to analyze, or whatever that you want to analyze with this kind of analysis with the Pareto diagram, and that's it.
Okay, before continuing to the example number 2, it's important to say that the most common data shown in the right axis is the percentage, but we also see that many Pareto diagrams show others data, not only the percentage, in order to compare the, the data. So once we know how to create a Pareto diagram, we can analyze a Pareto diagram. So in this diagram, we can see the failures in a company in the 2016. So we can see that the failures are dimensional deviation, corrosion, short circuit, tool marks, one part number, one part, late delivery, etc. So in the left axis, we can see the number of occurrences that goes from 0 to 700. But the most repeated failure is the dimensional division that are over 200, under 200. So in this, as I said, we can see the number of occurrences that are repeated, and in the right axis we can see the percentage that are summed to the previous failure. So if the dimensional correction are, for example, 30%, with the dimensional deviation and the corrosion are, I don't know, 55% sum between the two. So with the Pareto diagram, we can compare two information to data to see what are the things in common. In this, individually, we can compare the data of the number of times that each failure was repeated with the cumulative percentage that is added for each type of failure. And that's all. Thank you.